So what we need to make the sine law work is we need to have an angle and opposite side pairing. So this is really important. Okay, so this is where you can see whether we are able to apply the sine law. If we have an angle and opposite side pairing, that means we can apply sine law to a problem like this. Okay, because we can convert this into a sine ratio and then make a ratio with the length of the opposite side. So that's a key point. So I'm going to maybe make a point here. So make sure you have an angle and opposite side pair. Okay, so this is very important criteria for being able to use the sine law. Okay, so in this case we do. So we're going to set up the sine law. Okay, so when we set up the sine law, it looks like this. We take the angle, okay, and the opposite side. So I'm going to put, doesn't matter which way you write the ratio. I'm going to write the side and the side on top, sine on bottom. And this way, as long as we make sure that the other pair has the same orientation, so sine on bottom, so 35 degrees. Okay, so that's my sine, and then I'm going to call this side B. Okay, we're going to call that side B. And then we can solve for side B because we have a angle opposite side pair. So here's one pair. Okay, and I'm just going to highlight the other pair here. This is the other pair. Okay, as long as we can make that ratio, equivalent ratio, and only have one part to solve for, in this case we have this ratio pair that we can pair together, that's known. That way we can compare any other side and angle pairing to this known pair here. So solving for this, I'm just going to rearrange this first. So I'm going to end up with sine of 35 degrees over sine of 60 degrees times 25 is equal to B. And again, the reason why we have to use sine 60, we can't use 60 because 60-degree measurement is just kind of some random measurement that has nothing to do with length. When we do sine 60 is a ratio. Now we're talking about length measurements, and that's why we have to use a sine 60 to be able to do some math with this number and this number. Okay, otherwise there's no math that can be done between 60 degrees and a measurement unless we convert it into some kind of length ratio. So here we're going to do sine 35 divided by sine 60 and times by 25, and we get the length of B. So we get 16.56. So length of side B is equal to 16.56. It's going to write it in there, 16.56. Okay, so we've got two sides, two angles. We need to get the third angle and third side. Well, in this case here, since we know two angles of the triangle, we can find the third side by subtracting from 180 degrees. So it's going to be 180 minus 60 is 120, minus 35 is going to give us 85 degrees. Okay, we'll call this side C, and then we can solve for side C by doing the same thing. So I'm going to use my known ratio of 25 over sine 60. Okay, and that's going to be equal to side C over sine of 85 degrees. Okay, so again, we use our given angle side pairing to solve for some unknown angle side pairing. Okay, so this ends up being sine of 85 degrees over sine of 60 times 25 as a factor, and that's equal to length of C. That works out to be, okay, so what do we get here? We get 28.76. So C is equal to 28.76. Okay, so there's our triangle that's solved. Okay, we've got all three angles and sides. Okay, so that is, we've now solved that triangle. Okay, so here's another one. We have 12, 8, 25. What we're looking for is we're first looking for an angle and opposite side pairing. Okay, so we have that. So that indicates to us that we can use sine law. Now here we're going to solve for theta. And we have an angle and opposite side pair that we can write the same ratio to that yellow one. So first of all, I'm going to set up the known ratio. And this time I'm going to put sine on top. The sine 25 on top. And the only reason is because I want to solve for this angle. So I want to keep that in the numerator when possible. Now, you don't have to do it like this, but it makes it a little bit easier. So we're going to do sine theta over length of 12. Okay, so there's my known ratio. I'm going to use that known ratio to solve that unknown angle. In this case, I have to solve for the sine first. So I'm going to solve for sine theta. Sine theta is equal to 12 over 8, okay, times by 12, and then it's going to be sine of 25 degrees. Okay, so divide on bottom times on top, so 12 times sine 25 divided by 8, and that gives me a sine ratio of 0.6. And try to use at least three decimals, 6339, so I'm going to round that to 634. Okay, so then I need to solve for the angle, so I'm going to do the arc sine, so the inverse sine. Okay, my input is my ratio, my output will be my angle theta. Okay, so my angle theta, when I undo this sine, I'm going to get 39.34 degrees. Okay, so and again, I'm just going to use two decimals just to distinguish it from the ratios. So that equals 39.34 degrees. That looks about right. Okay, and then we're going to solve for the third side here. So we need to find the angle. So I'm going to subtract from 180. So I'm going to do 39.34. Sorry, so I'm going to do 180 minus 25 minus 39.34. So I get 115 degrees. 115.66 degrees in there. Okay, and that angle then, using that angle, I'm going to be able to get the length of that side. Okay, so I've got my parts here. The one last part, I've got three angles now. I just need the third side. And again, I have an angle opposite side pairing, so I'm going to use this angle opposite side pairing. I'm going to call that side B. We're going to say side B over sine of 115.66 degrees is equal to, and we'll use the known side, 8 over sine 25. Okay, and we're going to end up with B equals 8 times sine of 115.66 degrees divided by sine of 25 degrees. Okay, so putting that in my calculator, 8 times sine 115.66 divided by sine 25, I end up with 17.06. Okay, so B is equal to 17.06, whatever the measurements are. So I'm just going to put that to my diagram. Make sure when you answer these questions you're clear. You can even make a list of all your angles and sides. You can put it on your diagram, but just make sure that you're clear where all your solutions are. I'm going to also highlight all these values that I calculated. Right? So these are all the values that I calculated. Okay, so we start with 3 parts of the triangle. We need at least 3 parts, and then we can solve for the other 3 parts in this triangle. Now, there is a little bit of an issue here, and maybe I'll use the app to kind of highlight this, but when I look at this picture looks perfectly fine the way it is. However, when I've been given 25 degrees, 12, and 8, well, this 8 is kind of oriented, so this is obtuse. However, we can have this exact same information, these 3 pieces of information, and it looks to me that it's possible that there's a different triangle that could be formed. And it looks like this. This length of 8 could kind of show up like that. Okay, and we could have like an 8 centimeter length here, where this angle is acute and this angle is obtuse. So that's an interesting dilemma here.